Welcome to machine learning, and today we want to test the strength of linear regression. We want to check you through linear regression and want to test it if it is able to withstand noise, and let's see how it works. So we are going to say we are working with a dataset called life. Right, so this is our dataset we are working with. It has several columns, 22 columns, and we have our response variable, which is life expectancy, and we have all these other variables which are explanatory variables. We want to see how all these variables affect our response variable. So that's it. So however, for our linear regression, we are not going to use these first three variables. We are starting from the fourth one, which is the response variable. So we are going back here and select the variables that we want to work with. So I'm going to say use data. This is our new data set. Use data, and the data is going to be life, and we want all rows, but we want to select the columns. So how do we select the columns? So to select our columns, we are going to say we are starting from column number 4, which is the response variable, to the last column, which is 22. If you notice, we have 22 columns, and this is our fourth column, right? So that's it. So this will be our use data. Let's view that and see if we are right. Right, so we are starting from life expectancy to all these columns. Nice. So the next thing we want to do is now to do linear regression with what we have. So we can say fit one. We are fitting our first model. It's going to be LM. LM, that's the function for running a linear regression. So LM, then life expectancy. Life expectancy, that's our response variable. And if we say, if we put this comma and this full stop and a comma, it means we are saying let's run the model to all explanatory variables. Ordinarily we would list the explanatory variables here, but if we put a comma, a full stop and a comma, it means we are saying all the explanatory variables, and we specify our data, which is going to be use data, right? We check the summary of each one, right? So these are the results. We can see the coefficients for each explanatory variable. And now one interesting value to look at is the R squared. We have 83 R squared, which means our explanatory variables are doing a great job in explaining the variance in the response variable. 83 is a good one. So let's see now if we are to add noise to this data. Is our linear regression going to improve, or is going to capture that this is just noise? So let's do that. We are going to use rnorm. So rnorm, we are going to create a set seed. 1, 2, 3, 4. Right, so this will be our set seed. Why are we using set seed? We want to add new variables or new values to our dataset using rnorm. So if I'm saying rnorm, how an rnorm works is you need to specify your n, and the mean is going to 0 and standard deviation is going to be 1. So if I don't specify the mean and the standard deviation, by default it will be 0 and 1. So if I say rnorm 3, it means I need 3 random numbers, right? But if I say let's say I just call the same function again, you see the numbers are now different. I can do this again, the numbers are now different. But if I'm going to use set seed, it means I want reproducibility, I want the same numbers. Okay. Okay, so set seed, and you see now the numbers will be the same because we are using the same set seed. So that's why I'm putting this set seed, right? So the next thing is I'm going to create a new data frame called nonsense, which is going to be our noise data set. So I want it to be a data frame, is data frame. Then I want it to be a matrix. So I'm creating a data frame which contains a matrix. And how the matrix works is you need to specify the data. So the data that I'm specifying is going to be NA. So I'm just creating an empty data frame, and it is going to be NA. So this is a replicate function which works. You specify your data that you want it to be replicated, and you specify how many times. So I want it to be replicated number of rows of the use data, which is our data set that we're working with. So I want it to be replicated according to the number of rows. N row, it just means if I say n row of use data, I'm just referring to the number of rows. So I'm simply saying replicate 2,928 times. So if I say replicate, let's say replicate 2 times or 3 times, I'm going to have 3 replicated 3 times. So that's what I'm just saying, replicate NA 2,000 times. So then I'm going to multiply this by 100 because I'm going to use 100 columns. I will show you that. So after specifying my data, which is needed by the matrix, the next thing I'm going to do is I'm going to specify the number of rows. So a matrix, we want to know the number of rows. The number of rows is still going to be the number of rows of used data, our data set. And the columns now, number of columns, you need to specify this in a matrix, is going to be 100. So what I'm doing is I'm creating 100 columns, and the number of rows will be number of rows of our data set, which is 2,928. So our matrix will be 2,928 rows and 100 columns. So that's the matrix that I'm creating. So this is going to be the data set. So if we are to view this to see what I'm saying, if it makes sense, right, I can just say view. Right, so we have 2,928 entries, which is the rows, and 100 columns, right, with an NA. So we want to replace those NAs with random numbers. Then we put into our model and check the performance. So to do that, we are going to create a for loop. So how a for loop works is I'm going to start from I to, for I in I from 1 to number of columns. So what I'm doing is I'm specifying my I from 1 to number of columns of nonsense, which is our data set, right? So I'm just specifying that I want these columns, and I want my calculations to be done from the first column to the last column of this data frame. And the next thing now, what do I want to be done in the columns? So I'm saying in the nonsense data set, I want my ith column to have random numbers, which is now I'm going to use the rnorm. This one, I'm now going to use the rnorm function. So the rnorm, I want it to be n. How many times? I want it to be equal to the number of times of my used data, right? So that means on the first column, I'm going to have 100 rows with random numbers. Why am I saying 100? Because I'm going to have replication here of 100 numbers, and those numbers will be random numbers from rnorm. So this is what I'm just saying. Let's run this and see if this is going to work, right? Let's view the nonsense again. Right, so we can see we have now these random numbers. So we want to see how these numbers are going to affect our linear regression. So the next thing is we want to join this dataset with our original dataset. So I'm going to say use data 2 now. It's going to be 2 now. It's going to be C bind. I want to bind by column, and I'm going to say use data, the original data, and I'm going to add the new dataset with noise variables. So if I run this, I've joined those two. If you want to see it, let's view it. Right, so the first 2013 columns will be my actual columns, and the remaining are just noise up to 100. So that's fine. Let's see now how the model will perform. So I'm going to say fit to LM. So it's going to be life dot expectance and for all explanatory variables, and data is going to be the use data 2 with noise, life expectancy, and data life expectancy not found. Oh, let's see if I'm to say use data life expectancy. So why is it not found? Okay, I forgot this tilde. Right, so if we had to run this, then we take a summary, fit to. Right, so we have our results, so different coefficients for different variables. So we can see, right. Let's see the R squared. So we can see the multiple R squared is now 83.6. Let's see the previous one. It was 83.02. So you can see there is now a significant change in our R squared, which means linear regression is failing to capture that these are just random numbers. However, it is improving the model with random numbers. So that's one of the weaknesses of using a simple linear regression model and make decisions out of it. So from this, you would want more robust models like Lasso, which is what we are going to discuss in the next video, where we are going to show you how Lasso works and what it is and how it is going to capture the noise and remove all this noise from the model. Right, thank you so much for watching this video, and don't forget to subscribe.